strength is very low. Transient response of series RL circuit for DC excitation. Excitation means input. Which kind of input we are applying for the series RL circuit? A circuit having a series connection of resistor and inductor. For that circuit, we are applying the DC voltage as a input. Excitation means input. And for that kind of network, we are going to find transient response. Transient response means already we discussed response nothing but output of the network. The response of the network means output of the network. Which kind of response we are calculating? We are calculating transient response of series RL circuit for DC excitation. Nothing but there is a network. In that network, we are connected a resistor in series with inductor. There is a network. In that network, we are connected a resistor in series with inductor, and for that network we applied DC voltage as a input. If it is so, for this network we have to find transient response. Transient means there is a response means output. Transient response means uh, calculation of the output for the given network during the transition period. Once again, I will repeat. Transient response means calculation of the output of the network during the transient period, that is called as transient response. Okay, let us start this topic. Consider series RL circuit. This circuit, it is considered that transition takes place at instant time t equal to 0. So transition occurs at time t equal to 0. So if it is so, this transition period we are going to analyze with two cases, t equal to 0 minus and t equal to 0 plus. Okay, let the initial current through the inductor, that is I of t. Current is indicated by I of t. The initial current flowing through the inductor be denoted as I naught. Initial current is nothing but I of. So in the previous, while discussing initial conditions across basic elements, we discussed about inductor, that is IL of 0 minus we indicated that, that is IL of 0 minus we can represent it as a I naught. The initial current through the inductor denoted as I naught at time t equal to 0 minus. It means what? It is just before switch. Switch K is open. So at time t equal to 0 means switch occurs, means there is a connection between these two ends. But at time t equal to 0 minus, there is no connection between these two ends. Hence, switch, this is K. Switch K is open. Now, as voltage is not applied to this series RL circuit, there is no voltage. Current in this circuit will be 0. If there is no voltage, of course, there is no current. Hence, current through the inductor is 0 at this instant. But we know that current through the inductor cannot change instantaneously. That one already we discussed. Current through the inductor IL of 0 minus is equal to IL of 0 plus. Already we discussed. IL of 0 minus is equal to IL of 0 plus. This indicates that current through the inductor cannot change instantaneously. It means current before switch and current immediately after switch, both are same. So that one we discussed, that is indicated by the equation as, this statement we are going to express in mathematical equation as I of 0 minus before switch, that is equal to I of 0 plus, it is after switch. Both are same. Both are same. So both are same means that is 0. That is what? Initial current is indicated by I naught. So we are going to write it as I of 0 minus is equal to I of 0 plus. That is how much? That is 0. That is indicated by initial current is indicated by I naught. So let us represent equation number 1. Now, whatever we discuss up to it is what? It is before switch, initial condition. Now, if switch occurs, if the value of t is greater than or equal to 0 plus, it means at time t equal to 0 plus or more than that, then what happens? Switch K is closed. At time t equal to 0 plus, it becomes what? there is a connection between two ends. This switch becomes closed. This switch becomes closed. Okay, switch K is closed. Now apply the KVL. When switch is closed, apply the KVL to the circuit. So first, voltage across this one. How much? Current IT is flowing, I of t is flowing, hence current flowing like this direction. The arrow mark at is pointing towards this polarity, hence minus IT into R, minus IT into R, minus is there, minus R into IT. Very good. Next, and the direction of the arrow mark is pointing towards this polarity, hence it is minus what? L into dit by dt, and direction of the arrow mark is pointing towards plus, hence plus V equal to 0. So we applied the KVL to the circuit. For the simplification, I'm going to take this part except V, I'm going to take towards other side, hence it becomes plus, hence R into I of t plus L into dit divided by dt is equal to V. Okay, dividing both sides by R and rearranging the terms, we will get divide the both sides by R into I of t divided by R means R get cancels, only we will left with what? I of t. Here I will write only left with what? I of t. Next, plus as it is L divided by R dit divided by dt is equal to V by R. And rearrange the terms, L by R into dit by dt is equal to V by R. This term I will take towards the RHS, it becomes V by R minus IT. Okay, fine. Next, separating the variables. Let us separate the variables. Separating the variables means what? Here, observe here, I term is, current term is there. Okay, here also current term is there. So likewise, one side we have to take the current terms. Hence, separating the variables, dit, this term I will take towards the LHS, that is dit divided by V by R minus IT. And if you take towards RHS, it becomes R by L into dt. Current term is there, no? Correct. Here also current term is there, here also current term is there. Integrating both sides, we will get. We have the formula. We know that integration of 1 by x dx we can write log of ex, log base e of x. So let us integrate this equation. We will get minus ln v by r minus I of t, bracket complete, r by l t plus k dash, where k not k dash, where plus k. K is a what? It is a arbitrary constant. Let us represent as a equation number 2. K dash, not k, k dash. Okay, find k dash. How to find the value of k dash? This is the constant value. Then we have to find the constant value and we have to substitute the value here. So at time t equal to 0, we have I of t equal to 0. Now minus ln of v by r minus 0, because I of t is what? At time t equal to 0, it is 0. So it is 0 is equal to r by L. So what we consider? We consider the value, finding the value of k dash during the time interval t equal to 0. Wherever t is there in the above equation, substitute 0. Here if you substitute 0 means I of 0. I of 0 is how much? 0. And t equal to 0 means 0 multiplied by anything is 0 plus k dash. Okay. Next, k dash equal to what? Minus ln v by r. So represent as a equation number 3. Now substitute this equation in equation number 2. So what we are getting? Minus ln v by r I of t is equal to r by l t minus k dash equal to what? This one, minus ln v by r. Now rearrange the terms. This one I will take towards the LHS. Hence it becomes, this r by l t I will take towards LHS and this term I will take RHS. Then it becomes what? It becomes plus. ln v by r ln v by r minus it minus ln v by r, that is equal to minus r divided by l into t. So using this logarithm formula, ln of a minus ln of b is equal to ln a by b, log of a minus log of b, so a by b. So using this formula we can write ln v by r, this is acts as a, this acts as a b. Now we can write ln a means what, this one, b by r minus it divided by b, b is what, b by r, that is equal to minus rl by r minus r divided by l into t. Let us take anti-log. This is log term, correct? This is log term. Let us take anti-log. Then we will get v by r minus it divided by v by r. Anti-log and log get cancels, and anti-log means e to the power minus r divided by l into t. But we want what? Current. So current means, and one more step I will make use here, v by r minus I into t. If I take towards this RHS, it becomes what? V by r, v by r e to the power minus r by l into t. But we want it, correct? So it means take this I of t towards RHS and take this term towards LHS. It becomes v by r minus v by r multiplied by e to the power minus r by l into t. It is equal to I of t. Hence, current I of t, current flowing through the series RL circuit for DC excitation is given by V by R. I will take it common. V by R inside the bracket 1 minus e to the power minus R divided by L into T amperes. It is what? It is the current flowing through the series RL circuit for DC excitation. And with respect to this equation, we will see some cases. If V by R, the term V by R denoted by the response, or we can indicate as a steady state response or zero state response, then what happens? So see here, further, term V by R denoted by force response, or we can say steady state response, or we can say zero state response. Then term in the previous equation I am telling, V by R is indicated as zero state response, where V by R multiplied by e to the power minus r by l into t. It is indicated by natural response or transient response or zero input response. Remember, once again I will recall the equation. Here V by R, this term is indicated as steady state response or zero state response, or we can say force response, whereas this term is indicated as natural response, or this term is called as transient response, or this term is called as zero input response. Okay, with the help of this equation, let us calculate the value of time constant. Time constant is indicated by the parameter or notation tau. Time required for the current to rise to the 0.632 of its final value is known as time constant. What is meant by time constant? Time constant means what? We have maximum current value. When the time reaches 0.632 of its final value, then the corresponding time is called as time constant tau. So the time required for the current to rise to the 0.632 of its final value is known as time constant of series RL circuit and is given by T tau equal to L by R. Tau equal to L by R. So how it is correct? How you are saying that tau equal to L by R? When tau equal to L by R, how you are saying that it reaches 0.632 of its final value? Let us see with some cases. First one, at time t equal to tau, what happens in the equation? I of t equal to v by r minus v by r. What we taken? Tau equal to, sorry, t equal to tau. So first I will write equation. I of t is equal to v by r minus v by r e to the power minus r by l into t. First case, what we consider at time t equal to tau. So t equal to tau means what? L by r. Wherever t is there, substitute L by r. R by L into L by r get cancels. Only left with what? Minus 1. Hence it is minus 1. V by r minus V by r into e to the power minus 1. So e to the power minus 1 means you can take the V by r common. If you take the V by r common, so what left? 1 V by r outside, 1 minus e to the power minus 1. 1 minus e to the power minus 1 minus e to the power minus 1. If you simplify, you will get 0.632. V by R is nothing but what? Current. I equal to what? V by R. I equal to what? V by R. Hence, this is what? Current. 0.632 of what? Current. Hence, we can say that time required for the current to rise to the 0.632 of its final value is known as time constant. Let us go for, if t equal to 2 tau, t equal to 2 tau, 2 means, tau means L by R, tau means L by R, 2 tau means 2 into L by R. Substitute 2 into L by R. So what we are getting? We are getting only e to the power minus 2. E to the power minus 2. So 1 minus e to the power minus 2, we are getting 0.8646 of V by R. Next, t equal to 4 tau, we are getting e to the power minus 4. 1 minus e to the power minus 4, we will get 0.9816 V by R. Next, similarly, t equal to 6 tau, we will get 1 minus e to the power minus 6. Simplify this term, we will get 0.9975 V by R. So from these calculations, see, observe here, we increase the value of t. No, initially it is tau, next 2 tau, 4 tau, 6 tau, 8 tau, 10 tau, so on. So what we are getting, see, observe the value. Initially when it is tau, we are getting 0.632. As keep on increasing value of t, it is approaches very closer to 1. Now then next value we are getting 0.8, next we are getting 0.98, for the next value we are getting 0.9975. So as we are increasing the value of t equal to tau, 2 tau, 4 tau, 6 tau, so what we are going to conclude from this discussion, the initial rate of rise in current is high. So initial rate is very high, but after one time constant, after this one time constant, after one time, this is one time constant value, after one time constant means these values, after one time constant period, this rate slows down, slowly increasing, not drastically, slows down for further period of time. So ideally the current reaches steady state value at infinite time. So, but practically the current reaches steady state value after 6 tau or 8 tau. The substitute t equal to 8 tau or 6 tau, see, it is very closer to 1. It is very closer to 1 means I equal to V by R. I equal to V by R means it is an ideal current. Practically we are not getting this current. So whatever the current is there in the network, we are not getting exactly same value. So that is ideal current. I equal to V by R is ideal current, but practically means not very, it is very closer to 1. So it is 0.9975 V by R. So all these calculations we are going to represent on the graph. That is, there is a graph or current across time. Horizontal axis represents time and vertical axis represents current. Now, for the first time constant, the current reaches what? 0.632 of V by R. As the value of tau increases, 2 tau, 3 tau, 4 tau, 6 tau, So initially it drastically increases. Current rise is very high. Initial nothing but first tau value. It is very high. But as keep on increasing the value of tau, there is a slows down. There is an increase in the current is very slow. So this is the discussion about time constant. Now let us calculate voltage across. We calculated current across series RL circuit for DC excitation. Now let us calculate voltage across inductor L. Voltage across inductor L is given by VL of t equal to L into dit by dt. So make use of equation 5. Put equation 5 in the above equation. So equation 5 means I of t. Equation 5 indicates that already we calculate current. This current value you have to substitute here. Then VL of t equal to L differentiation of current V by R multiplied by 1 minus e to the power minus R by L into t. Let us differentiate this term. L as it is outside, differentiation of V by R minus differentiation of V by R into e to the power minus R by L into t. Differentiation of V by R, there is no t term, hence it is a constant. So differentiation of constant is 0. Next coming to here, t term is there. So V by R is constant, take it outside. Minus V by R outside. Differentiation of e to the power minus R by L into t, that is by, if you are differentiating, we will get minus R by L into e to the power minus R by L into t. Simplification, further simplification, minus into minus plus, okay, uh, V by R into R by L, R get cancels, R get cancels, one more L is there, L divided by L get cancels, only left with what? V. Hence VL of t equal to V multiplied by e to the power minus R by L into t, equation number 7. Equation number 7 will give the voltage across inductor. Okay. Now let us calculate voltage across resistor. That is indicated by VR of t. VR of t equal to R into IT. IT is already calculated. Substitute here V by R minus V by R into e to the power minus R divided by L into t. So let us take V by R common. If I take V by R common means R as it is. I have taken V by R outside. Left with what? 1 minus e to the power minus R by L into t. This R and this R get cancels. Left with what? Only V. Hence V R of t equal to V into 1 minus e to the power minus R divided by L into t. Equation 8. Equation 8 will give what? Voltage across resistor.